What is time? What exactly is our understanding of time? I want to attribute this thinking to the potential of time and how technology could eventually lead us to navigating through time as we know it. In physics, time is often considered one of the 4 dimensions of space-time, along with 3 spatial dimensions: length, width, and height. This concept was introduced by Albert Einstein's theory of special relativity, which showed that time is not an absolute, independent entity, but rather interconnected with space. The presence of mass and energy warps space-time, creating gravitational fields that influence the flow of time. Determinism plays a role to these concepts as well. Determinism is the idea that every event is determined by preceding causes. This raises questions about nature of free will and whether human actions are predetermined by the laws of physics. At the core of our discussion, we will explore the show Devs, Christopher Nolan's Tenet, and the rumored chronovisor within the Vatican. Speculative fiction is a way to imagine fantastical worlds and technological advancement, but what if we could learn from these ideas? I'll start with what I feel is the least thought out concept: the chronovisor. The concept of the Vatican's chronovisor originated from the writings of Italian priest and scientist Father Pellegrino Maria Ernetti, who claimed to have co-invented the device with a team of scientists in the 1950s. According to Ernetti's accounts, the chronovisor was a machine capable of capturing and viewing events from the past by accessing what they called chronovibrations imprinted in space-time. According to Ernetti's accounts, chronovibrations are residual electromagnetic vibrations imprinted in space-time by past events. This idea leads us to the show Devs. Written and directed by Alex Garland, released in 2020, Devs follows Lily Chan, played by Sonoya Mizuno, a software engineer for Amaya, a quantum computing company run by Forrest, played by Nick Offerman. Lily soon becomes embroiled in the mysterious death of her boyfriend, who died on the first day of his new job at Amaya. Devs revolves around a secretive quantum computing project of the same name. Quantum computing is an emerging field that utilizes the principles of quantum mechanics to perform complex computations at unprecedented speeds. The show portrays the immense computational power of quantum computers, highlighting their theoretical potential for solving intricate problems that classical computers struggle with. At the core of quantum mechanics lie the concepts of superposition and entanglement. Superposition allows quantum particles to exist in multiple states simultaneously until observed, while entanglement creates a correlation between the properties of particles regardless of distance. In Devs, these quantum phenomena are central to the project's ability to access information about past events. The show also explores the implications of determinism on the characters' choices and actions. At the core of determinism lies the principle of causality, which states that every event has a cause. According to determinism, events are linked in a chain of cause and effect relationships, leading to a predictable and unbroken sequence of events. Determinism often aligns with reductionism, the belief that complex phenomena can be explained by reducing them to simpler underlying components and their interactions. In this reductionist view, the behavior of macroscopic systems, such as human actions, is ultimately governed by the interactions of their constituent particles. You get the gist of it. The notion of determinism has historical roots in Pierre-Simon Laplace's concept of a hypothetical entity known as Laplace's demon. This demon possesses perfect knowledge of the positions and velocities of all particles in the universe, enabling it to predict all future states with absolute certainty, assuming the deterministic nature of physics. In the context of classical mechanics, determinism was thought to be the natural outcome of a clockwork universe, where the behavior of physical systems was thought to be fully determined by Newton's law of motion. However, with the advent of quantum mechanics, the determinism of classical physics was challenged by the inherent probabilistic nature of quantum systems. Contrast to determinism, we have quantum indeterminacy. quantum mechanics introduced the idea of inherent uncertainty at the microscopic level, leading to probabilities rather than deterministic outcomes. Some interpretations suggest that at the quantum level, events are inherently probabilistic, challenging the strict determinism of classical physics. That brings us over to Tenet, which plays around with a little bit of a different concept of time, physics, and even philosophy. The central scientific concept in Tenet is inverted time, where certain objects and individuals move backward through time. This phenomenon is linked to the concept of entropy, which is a measure of disorder and randomness in a system. In the movie, inverted objects have negative entropy, meaning they are moving in a direction opposite to the normal flow of time, defying the natural arrow of time where entropy increases with time. The movie introduces temporal inversion, allowing objects and people to move backward in time without causing paradoxes. However, it also presents a variation of the grandfather paradox, wherein potential inconsistencies arise when actions in the past affect the future and vice versa. Tenet suggests that the universe may have built-in mechanisms to prevent paradoxes from occurring. Time dilation is a real phenomenon predicted by Einstein's theory of relativity. It occurs when an object moves at a significant fraction of the speed of light or experiences strong gravitational forces. In Tenet, time dilation is depicted on a larger scale, where entire environments can experience time differently depending on their relative motion or gravitational fields. It's also worth noting that time dilation plays a key part in Interstellar, also by Christopher Nolan. In that film, due to a planet being so close to a black hole, every hour on that planet, 7 years pass on Earth, and that all falls into Einstein's theory of relativity. Back to Tenet, the movie briefly touches on quantum entanglement, a strange phenomenon in quantum physics where two or more particles become correlated in such a way that the state of one particle is directly related to the state of another, regardless of the distance between them. In Tenet, this concept is used to explain how inverted objects interact with their non-inverted counterparts. All of this is conducted by a fictitious advanced technology that enables time inversion and manipulation. While the specific mechanics of this technology are fictional, they draw inspiration from cutting-edge research in quantum computing and theoretical physics. And at the core of this film, we get references to Maxwell's demon. Maxwell's demon is a thought experiment proposed by the Scottish physicist James Clerk Maxwell in 1867. The purpose of this intriguing hypothetical scenario was to explore the implications of the second law of thermodynamics, which is a fundamental principle in classical thermodynamics governing the direction of heat flow and the increase of entropy in closed systems. So then you take Maxwell's demon, which is an imaginary being, a microscopic intelligent agent or demon, capable of controlling a small door or gate that separates the two chambers of gas particles. One chamber is initially hotter, the higher temperature, and the other is colder, the lower temperature, and the door between them can be open or closed by the demon. The demon's task is to observe individual gas particles as they approach the door and selectively allow only the fast-moving high-energy particles to pass from the colder chamber to the hotter chamber, and vice versa. By doing so, the demon seemingly reduces the temperature difference between the two chambers, leading to a concentration of high-energy particles in the hotter chamber and low-energy particles in the colder chamber. Maxwell's demon's actions appear to contradict the second law of thermodynamics. By selectively sorting particles, the demon seems to create a temperature gradient without expending any work or energy, seemingly violating the law of increasing entropy. This would suggest that the creation of a perpetual motion machine of the second kind, which is a device that continuously extracts useful work without any input of energy, contrary to the principles of thermodynamics. The resolution to Maxwell's demon paradox lies in the fact that the demon itself requires energy and work to perform the particle sorting task. Observing, analyzing, and moving particles requires energy expenditure and measurement, which would contribute to the increasing entropy of the system, compensating for the seemingly decreased entropy caused by the demon's actions. In modern physics, the concept of information entropy plays a crucial role in understanding Maxwell's demon. Information entropy is a measure of the uncertainty or surprise associated with a given set of information. When the daemon observes and records the particle positions and velocities to make decisions, it creates an increase in information entropy, and this increase precisely accounts for the reduction in thermodynamic entropy. The total entropy, including both thermodynamic and information entropy, still follows the second law. So while it's a way to somewhat conceptualize the machine that they utilize in Tenet, it is also in a way contradicted by the notion that, you know, there is still entropy that exists, therefore not exactly going against the second law of thermodynamics. Funnily enough, Tenet also utilizes a red and blue color scheme which parallels many visualizations of Maxwell's daemon. It's also worth noting that Devs refers to a concept called Laplace's daemon, as I mentioned before. Got a lot of demons going on here, I guess. So what does this all mean? We have a myth and 2 sci-fi movies. What? I don't get it. Well, I'm glad you asked. Time is a construct, and like any other construct, therein lies the opportunity to navigate or exploit it. I believe we can eventually get the opportunity to investigate the past. Time dilation can bring us to the future, but what if I said you'd be able to view the future too? So this next section, we talk about temporal correlations, which refers to statistical relationships between events or phenomena that occur at different points in time, then examining how changes in one variable or event correspond to changes in another variable or event over a specific period or sequence of time. And we're also talking about quantum information, which refers to the fundamental unit of information encoded and processed using the principles of quantum mechanics. In classical information theory, information is typically represented in binary digits or bits, which can have values of either 0 or 1. In quantum information theory, the basic unit of information is called a quantum bit or qubit. Investigating the nature of time entanglement and temporal correlations within quantum information could help provide insights into the underlying structure of time itself. This could involve exploring concepts like time-entangled states and how they encode information about past and future events. Also, if we look at quantum computing with a CTC, which is a closed time-like curve, that's a theoretical construct in space-time that describes a path or trajectory of an object or particle that loops back in time and returns to its own past. In other words, a CTC is a path that allows an object to travel through time and return to an earlier moment in its own history. I think a good example of this is talked about, I forgot who mentioned it, but they said that if you were to make a time machine, you would only be able to go back to the point in which that time machine was created. Similarly to how you can traverse a highway or a road once that road is built. You can't really traverse a road before it exists. So that's kind of how I look at CTC. But if we were to research the potential existence and properties of a CTC within the context of quantum computing, it could offer a unique perspective on causality and time travel. Understanding how quantum information interacts with CTCs could lead to novel insights. Quantum computers have the potential to simulate complex systems, including those involving the dynamics of time. Designing quantum simulations that model the behavior of particles and events across different points in time could provide the valuable insights into the nature of temporal interactions, right? Retrocausality is the theory that future can influence the past. So that in mind, investigating the theoretical implications of time reversal and retrocausality within the context of quantum mechanics is crucial. This could involve exploring the consequences of retrocausal influences on quantum systems and the potential to observe information from the past using quantum entanglement. Quantum this, quantum that. Yeah, it looks like a lot of word vomit. You throw it up on a Wikipedia page and it's all this complex math equation stuff that at this point amounts to nothing, in the sense that a lot of it's theoretical. But as we progress through time and we get through these advances in technology, I believe that in the future we will be able to view the past as it was and view the future as it could be.